Okay friends, welcome to part 2 of our video presentation on chapter 6 that talks about managerial support systems. In this part of our video presentation we'll continue talking about different types of management support systems, or another term for management support systems, in fact I think it's a more common term, is management information systems. So we'll continue talking about various types of MIS. Now, the next type of management information systems or managerial support systems that we will talk about are the so-called executive information systems, or EIS. Some types of business intelligence systems are also classified as executive information systems or executive support systems. So what do we mean by executive information systems or executive support systems? Well, those are hands-on tools that help focus, filter, organize, but most importantly, aggregate information so that an executive can make more effective use of it or can make effective decisions at the strategic level. The user base of executive information systems is expanding and now encompassing not only top executives but mid-level managers, all levels of managers within an organization. Now, one thing to understand about executive information systems or executive support systems is that those are very high-level systems that focus on competitive information, meaning very high-level strategic internal and external information that is essential for overall performance of an organization. So what do executive information systems do? Well, they deliver current information about business conditions in aggregate form. The information is highly filtered and summarized because executives may not have time or knowledge about technicalities or little details. Again, it's competitive information, which means like assessment and insights about high-level trends within the internal and external environment. It's one of the most important goals of executive information systems is to make information accessible, meaning easy to understand and analyze for senior managers, because senior managers, as you well know, are very busy, and their job is more on the dimension of leadership, strategy formulation, so they may not have time or abilities to dwell in little technicalities and details. So the system needs to provide information that is highly aggregated and also can easily be understood and interpreted or used by executives. So they are designed to be used without intermediary assistance. Often they rely on graphics and various data communication and storage methods to make data more accessible and more convenient to use for executives. Now, there are a lot of vendors out there that provide specific applications that support executive decision making. Again, you have big players such as SAP and SAS. Those are big analytical systems. In the case of SAP, this is a big enterprise system, and those kind of systems, they would have like a module or standard or separate application that is geared specifically to senior executives. So here you see a representation of a typical executive information system, or the so-called executive dashboard. Because typically data that is coming from an executive information system is visualized and worked with by an executive with the help of the so-called dashboard. So here we have the so-called key performance indicators, let's say related to sales, product relationships, some trends, monthly trends in sales volume and so forth. So very high-level strategic information that an executive can easily understand and use in his or her work. Okay, the next type of managerial support systems that we will discuss are the so-called knowledge management systems. But what is knowledge management, or KM? Well, simply speaking, you can define KM as a collection of practices to manage organizational knowledge. Now, if we expand the definition, it can be said that knowledge management involves strategies and processes for identifying, creating, capturing, organizing, transferring, and leveraging knowledge held by individuals and the firms. Just to give you a bit of background on knowledge management seems to be like a relatively new or modern view on organizations. A lot of theorists, a lot of thinkers nowadays, they view organizations as nothing more but knowledge management systems. Indeed, if you think about at least some types of organizations, let's say consulting company, it's easy to see that their business largely involved using knowledge for helping, others, make effective decisions or improve their operations and improve their overall organizational performance. So it's all about knowledge. And then there is also that argument that nowadays, many countries are transitioning from manufacturing-based economies to service-based economies. And as you know, service companies they are very information intensive, and therefore they need to they heavily rely on knowledge in their daily operations and in providing their services. Again, if you think about typical organization, I don't know, let's say a typical service organization, let's say an investment company, then again their business is largely about knowledge. In other words, investment companies, they generate knowledge about investment opportunities, and they sell that knowledge to potential clients who are seeking investment advice, and also they use this knowledge for making their own investment decisions, right? So this is like a way of looking at organizations, to view organizations in terms of the kind of knowledge they have, how they use this knowledge, and how this knowledge is applied in various areas to produce valuable products and services. So what do we mean by knowledge management systems then, or KMS? Well, those are systems that support organizational knowledge. So typically, it's a collection of various information technologies that facilitate the sharing and transferring of knowledge so that it can be used and reused for decision making or doing anything that would add value to an organization. But at the heart of knowledge management system is that idea that information technologies can be used to enable, meaning to help people and organizations to learn from others, and by doing that to improve performance of individuals, groups, and organization as a whole. So basically it's about helping individuals generate, store, and manage knowledge so that they can improve their work, and as a result of that, improve performance of the organization as a whole. Now, as you know that saying that knowledge is power. So knowledge can be used to improve operational processes. I mean, indeed, if you know how to do something better, then you will be able to do things faster in a more efficient way. It can also help you in change management. If you know how change should be carried out, in other words, it will help you improve your processes, change your processes. And it will also assist you in knowledge reuse. I mean, think about it. If knowledge is the most crucial, the most fundamental asset of your organization, then it's better to reuse that asset as opposed to creating knowledge sets, knowledge asset every time you have a new project. In fact, a lot of consulting companies, that's exactly what they do. They reuse their knowledge. A company like any kind of consulting company, let's say McKinsey, they would have like a huge knowledge base or database of cases, meaning prior engagements with clients. So whenever they have a new client, what they would do, they would typically pull information from previous engagements to see what they did in the past, what worked, what didn't work, and then they will use this organizational knowledge for helping their new client. And then, all those operational improvements, they also lead to market improvements or in a separate in a separate area, knowledge can be used for improving, that kind of external performance. For example, increase sales through better knowledge of what's in demand in the market, lower cost of products and services, and then customer satisfaction if you know more about customers, how to serve their needs. So, I think there's no need to explain much here. Of course, knowledge, if you know something about internal operations or external environment, meaning the market, then you can improve your own organizational performance, and as a result of that, make your company more competitive and profitable. So obviously, knowledge, useful knowledge is valuable by definition, I would say. So here's an example of a knowledge management system being implemented in a pharmaceutical company or pharmaceutical firm. So first of a system would start with the people side. A knowledge management team needs to be formed to develop and implement and maintain an organization-wide knowledge management system. Some members of this team, they will be appointed to be coordinators within communities of practice, and communities of practice involve professionals, that share similar knowledge base. So, for example, engineers versus managers versus accountants. Nowadays, and then the system would typically involve some kind of portal, either web-based portal or internal portal for uploading knowledge, managing knowledge, discussing knowledge, let's say through discussion forums, and any member of the community can use this knowledge base or knowledge system for retrieving knowledge and also sharing his or her own knowledge. Now, as you saw from the previous slide, like on the technical level, there's nothing complex about implementing knowledge management systems. I mean, it can be as simple as some kind of network with a collection of files, or network that can be used to run discussion forums and file exchange, like let's say SharePoint. So technical implementation is very easy, I mean relatively easy. What is challenging though is dealing with the human or organizational side of knowledge management systems. Now, some of the critical areas in knowledge management, or when it comes to implementing knowledge management systems, is knowledge contribution. Making sure that individuals actually contribute to the knowledge system. Now, individuals, they may be reluctant to contribute to the knowledge system for various reasons. Maybe they don't have time for it. Maybe they feel that by releasing their knowledge, making it public, sharing it with others, they will lose their legitimacy, their power within an organization. Because of that, it's very important to have senior leadership commitment so that they can, instill appropriate incentives so that people are actually willing to share knowledge. And then knowledge reuse. I mean, once knowledge is generated, there needs to be incentive for people to go back and read the manual, so to speak. In other words, they need to be able, they should have enough awareness and enough motivation to actually reuse knowledge so that they don't make the same kind of mistakes or don't initiate studies that were done in the past. Now, for me, it was a big problem in my work because I found out that I initiated at least one important project that was already implemented in the past and that failed miserably. And to my great surprise, I found out that the kind of, not through a formal knowledge management system, by talking to people, is that the problems I was struggling with were exact problems that previous employees were facing, and my solutions were almost identical to the solutions that they developed. But it took me a lot of time and a lot of hard thinking to develop those solutions in the absence of knowledge management system, because I couldn't just look up, previous projects that were similar to mine. So in my case, I just didn't have any formal knowledge management system. I did retrieve a little bit from SharePoint, by looking at their files and the policies and the documents in general that they developed. But I wish there was a formal knowledge management system that would help me reuse what people in my organization learned in the past. Okay, artificial intelligence. Again, artificial intelligence is not like a separate standalone system. It's rather like a technology or a field of endeavor that is a part of other managerial support systems. Artificial intelligence, or AI, it's all about developing algorithms and data repositories and knowledge bases that would help computers act in a way that approximates human intelligent behavior. So, for example, to recognize natural languages, to recognize visual images, let's say, some kind of map situation, some kind of situational development on geographical map, let's say, for evacuation. Then you have like those genetic programming, evolutionary design, where systems they learn from their past experience, just like humans, and develop themselves. So basically, I would say artificial intelligence, is a term used for the science of algorithms, for the science of creating computer algorithms that approximate human learning and human decision making. And most of the applications of artificial intelligence systems, they are in those fuzzy, unstructured scenarios that are sometimes easily handled by humans, but typically they are very hard for computers to handle. Now, some widely known applications of artificial intelligence in business, by using computers, are the so-called expert systems and neural networks. Now, expert systems, they're the most common ones. Basically, what they do, they capture human expertise, and then they make decisions similar to the way decisions would be made by humans. But of course, computers are a bit better in making decisions, especially if they're structured ones, because computers, they don't get tired, they don't make mistakes, they don't get driven by emotions. And there is a field of endeavor called knowledge engineering. Basically, those are people who develop conceptual descriptions of a particular knowledge base so that computers can use it. An example of an expert system would be like some kind of loan application system. So that system would retrieve certain parameters about a potential loan applicant, let's say his or her age, income, residency at one address, length of employment with the current employer, all those things. And then by using a bunch of if-then rules, like if age is greater than this and employed with the company for more than 5 years, then qualified for a loan above X, right? So it's basically using this kind of judgment that is human judgment that is formalized with the help of if-then rules. Now, a typical expert system contains of a knowledge base. Basically, this is where you store all those rules. If-then, of course, I mean, if-then is a very simple rule. There are more sophisticated algorithms that are being stored. And then you have inference engine that basically helps helps those systems recognize problems and apply their knowledge base to those problems. And then there is a user interface so that users can work or interact with that system directly. So this is like a conceptual description of an expert system right here. Again, just like a brief comment, expert systems, they can be developed internally by organizations. They can also be purchased. There's one famous example by IBM. They've been experimenting with expert systems. So they have this general expert system. I forgot how it's called. I think it's called Watson. Named after the founder of IBM. It's a expert system that has a huge knowledge base, and basically that expert system is supposed to answer like all kinds of questions. So it's largely driven by artificial intelligence. So here you see like some examples of expert systems being developed by various organizations. Neural networks, I mean, it's a big subject, it's a vast subject. Again, I wouldn't call it like as a separate system. It's more like an algorithm. Now, as you can tell from the name neural network, it again mimics the way humans make judgments, or the way humans learn. Now, you probably know that your brain consists of a number of neurons, and when you learn something and when you store some kind of skill or some kind of information, basically what you're doing, you're developing certain path in your brain consisting of neurons. Okay, so basically this is how those algorithms based on neural networks work. They work similar to human brain. They try to recognize certain nodes, meaning like certain parameters in the environment, let's say certain scenarios, and then links and connection among those nodes. And then that's their learning. And then they use those neural networks or those nodes for evaluating certain scenarios and coming to a conclusion or a solution. So neural networks is more like of a sophisticated and natural human-like algorithm for learning and decision-making using computers. So it can be used like for fraud detection, for recognizing fraud, for profiling customers, for issuing diagnoses to humans, and there are many other applications of neural networks. Now, virtual reality, again, was a very hot topic up until 1990s. Everybody was talking about it. If you ever have a chance, watch a movie called Hackers. That was one of the first computing movies, popular computing movies that was released even before Matrix. That was the second important computing movie. So that whole movie called Hackers is based on that virtual reality idea that humans will be living in this virtual reality and using their avatars, to represent themselves, and most of their life, most of the struggles will be in that virtual reality. But that's more on the entertainment side. There are some non-entertainment uses of virtual reality, like in training, let's say training somebody to be a pilot, in design, creating a design of a building and then walking through the design to see how humans would perceive this new design, for meetings and social collaborations. So here you see like some examples of different uses of virtual reality in different fields of endeavor. It's just like one quick example of virtual reality being used in real estate to represent a particular real estate asset being offered for sale. Now, one thing I would like to show you in relation to virtual reality is a web-based product called Second Life. Yeah, I was a bit worried because you never know what they're going to show on the front page, because sometimes they have objectionable avatars, so to speak, in their system. Well, anyways, Second Life was a very hot trending topic, I would say, between 2006 2009. If you ever have time, I suggest you explore Second Life. But basically, it's that web-based virtual reality / social network. So Second Life, it's a company. Second Life is a product by a company called Linden Labs. I think they still own Linden Research. It's a virtual reality. They maintain a bunch of servers that contain those 3D virtual worlds, and you as a user, you can build your own avatar that will look pretty much like anything or anybody, and then you can travel to this world. And there's a game component to it where you can do certain things. You can dance, you can interact with people and objects, you can build your own buildings. One thing about this virtual reality that I found interesting is that they had their own economy being developed. In other words, some people, they became like professional landlords. So they would build real estate, like for example, they would build islands and houses, and then they would sell that real estate, the land or even the buildings, to other users, other companies. Some marketing companies that would specialize in designing presence in Second Life, or companies, let's say a travel agency would order a small version of Paris to be built in Second Life so that they can show avatars, what kind of exciting things they can see in Paris, and after that make them sign up for a tour to Paris. Adult entertainment, without expanding on that, was a big popular field of endeavor in Second Life. I think eventually it got banned because there were many complaints from people about this. So I think anything related to adult theme is now prohibited, or there's like a separate island for that where you have to have your age verified. So there was a lot of promise. A lot of people viewed that Second Life will become the platform for something that futurist and technology sci-fi writers were talking about for a long time. Eventually it didn't take off. I'm not sure what's happening now. I think they still have like a strong community of around 1 million users, but it's not nearly booming. If you ask me why Second Life didn't take off, I think the reason is that they couldn't find like any good applications that would clearly demonstrate values. Let me give you one example from my field, which is using Second Life for virtual campuses. So what some universities would do, they would like build some kind of campus, and then avatars, meaning students would use their avatars to come to lecture. And when you come to lecture, it's like basically a lecture hall. So you sit there as an avatar, and then there's an instructor avatar, standing in front of the board. And then they start basically transmitting voice information. And then the question becomes, is it really useful? Why do you need to listen to a lecture as an avatar? Why don't you do what I'm doing right now, which is like voice over PowerPoint? It's cheap, simple. You don't have to run any kind of 3D server for that. Some organizations, they went a bit further. They built like natural, virtual 3D models of certain environments, let's say of a factory, to train their students. But overall, it was expensive. There were a lot of technical glitches that companies had to deal with. And all those led to the fact that just companies couldn't find any kind of viable, profitable use of this virtual reality. But again, with technology, sometimes there's more subjectivity, there are more emotions, there are more fashion-like behavior with technology than anything else, even with clothing, even compared to clothing fashion. So let's not make any conclusions. Who knows? Maybe Second Life will pick momentum again, as it frequently happened. Things in the world of technology go in and out of the fashion, just like data mining and decision support systems. They were a hot topic up until 90s, then they kind of died, their popularity died off. Now with the resurgence in data analytics and business intelligence, and with the emergence of big data movement, everybody's talking about decision support systems again. So who knows, maybe virtual reality will pick up, and Second Life will become the new most important computing platform of the future. Okay, friends, so that's it. That concludes part 2 of our video presentation on Chapter 6. Thank you for listening.